as you're getting started on this form up here, guys, there's actually two different ways you could do the first question. So the thing is, this cube root of 32 does not come out whole, right? So you're going to have to simplify it, though, because there's a perfect cube that goes into 32. So the thing is, you could either simplify first, or you can actually combine like terms first because they are like terms. So just because there's two different ways to do it, I'm going to get us started here and then let you finish it. So remember, we learned yesterday to add and subtract radicals, they have to be like the same index. So this little number of 3 has to be the same, and it is, and the same radicand, the same number under here, and they are. So that's what I'm saying is we can go ahead and subtract them right away. We have 4 of them minus 1, so that's going to mean that we have 3 of them. Okay, but why you don't see this as any of the answer choices is because it says it has to be in simplest form. That's the part I'm going to let you work on your own, and I also want you to try the second question on your own. So let's talk about the cube root of 32 real quick. So that's not going to be on your perfect cubes list. If you take the, remember guys, taking the third root is the same as raising it to the 1/3 power. So you could check on your calculator 32 to the 1/3 power. It's not going to come out whole. But there is a perfect cube that goes into 32, and that would be 8. So remember, you're going to write this as the cube root of 8 times the cube root of 4, right? Because 8 times 4 equals 32. Now, don't forget that there was this 3 in the front. I'm going to add that back in now, which gets multiplied. Let's put a dot there. So after we go ahead and take the cube root of 8 to get 2, it's going to get multiplied by the 3, right? Because again, if there's no symbol in between stuff, it means multiplication. So you're doing 3 times 2. So 6 times the cube root of 4. B would be your final answer for that one. When we move on to the next one, again, guys, we had a property that says when this is a product, we're allowed to split it into parts. So you're going to kind of be thinking about it in pieces, okay? Like, what is the cube root of 32? Now, this is nice because we just did the cube root of 32. It happens to be the same number. So we already know, like, the cube root of this is going to be, we're going to be using 8, right? Because 8 is a perfect cube. The cube root of 8 is just 2. I'm going to leave it like that for a minute. The cube root of x to the 8th. Guys, let's pretend for a minute, what if it was x to the 3rd? We learned yesterday that if you raise something to the 3rd, but then take the 3rd root, like it would just be x, right? So we're going to talk about that more in a second, but I'm going to, I didn't really need to make that long probably. So it's not x to the 3rd though, it's x to the 8th. So, but every time you have an x to the 3rd, the 3rd root of x to the 3rd would just be x, like an x would come out front. So if you had another x to the 3rd in there, which we do because 3 goes into 8 more than one time, right? Then another x would come out front because every time you take the 3rd root of x to the 3rd, it just equals x. But there'd still be more, like that's only x to the 6th so far, right? 3 plus 3, you'd have to have 2 more for it to add back up to 8 again, right? Guys, remember we said yesterday you can kind of do 8 divided by 3? Let's think about literally long dividing it for a second. Like if I take 8 divided by 3, it goes in 2 whole times. That's why we have 2 x's on the outside, because there's 2 whole groups of 3 in there. So, and actually, by the way, we're just going to go ahead and write it as x squared. But think about 2 times 3 is 6. Like those are our x to the 3rd and 3rd. That's 6. There's 2 left over, right? That's why there's going to be 2 on the inside here still, okay? Let's go back to the number part for a second. I probably should have gone ahead and simplified that. The cube root of 8 is just a whole number, too. That's why it comes out on the outside, because it's whole. The cube root of 4 isn't. The 4 is going to have to stay on the inside. So now let's think about the y's. So the cubed root of y to the 30th, again, every time you have a group of 3, a y can come out front. If you had another group of 3, another one would come out front, and so on. You need to think, how many groups of 3 would there be? I don't want to write them all out because there's 10. How do I know that? Because 30 divided by 3 is 10. You'd have y to the 10th out front. No y's left inside this time because 3 goes into 30 evenly. So 2x squared y to the 10th times the cube root of 4x squared. That would be your final answer for that one. Any questions before we go on to our new lesson about what we did yesterday? Wrong. So we're going to get into 3.3 today. We're going to be spending 2 days on it because today is going to be function operations and tomorrow is going to be something called function composition. So before we can get into learning the actual material of the section, there's a little bit of background information you need first. So back in Algebra 1, sometimes you had to write inequalities, right? Like this inequality right here, we should read it starting with the x. It says x is greater than or equal to -2, but less than or equal to 3 at the same time. I'm going to draw a picture of what that means on the number line. Basically, it means all the numbers from -2 to 3. Like, do you see how that picture matches the inequality? Are you good with that? So in Algebra 2, sometimes we, instead of writing it as an inequality, that picture I just drew on the number line, sometimes we write it with what's called interval notation, and it's just a different way to write this. So I want you to think about how the graph that I just drew starts at -2 and it stops at 3, right? So when you do interval notation, you're going to write where it starts and then a comma and where it stops, but then you're going to put brackets around it. I'm going to talk about those brackets more in a second, but I need to go on to the second example first because look how similar that first one is to the second one. The only difference from here to here is that it doesn't have the equal to anymore. So do you remember from Algebra 1 how your picture changes if x has to be greater than or equal to -2, like it's not allowed to be equal to it this time? Do you remember from Algebra 1 how we put like an open circle at -2? We actually talked about that once this year too. But same thing over here, it doesn't say it can be equal to 3. It says it has to be less than 3. Meaning if I'm drawing a picture, I put like a hole at 3 because 3 is not included this time. So in interval notation, like technically the starting point is still -2 and the end point is 3, but because -2 itself is not included, you're going to use what we call an open bracket instead. So just look at, now I'm going to go back and explain to you this type of bracket. We call it a closed bracket. Means that -2 is included, like it'd be filled in. You're allowed to have a value of -2 because it says it can be equal to -2. If it's not, same thing with 3. It said that it could be equal to 3, so we use what's called a closed bracket. If it doesn't have equal to, so it can't be equal to -2, we put this kind of bracket. It's called an open bracket. It looks like a parenthesis, okay? So we're going to look at a couple other types of sets of numbers real quick. So on the first 2 examples we just did, we had a starting point, -2, and a stopping point, 3. What if we don't have a starting and stopping point? Like, what if I want to talk about all real numbers in the whole world? Well, on the number line, that means, again, there's no starting point or stopping point. It's like saying I'm making a graph of the whole entire number line. Like it goes down forever and ever past what you see there, right? Like it doesn't stop at -5. It actually goes down, -6, -7, -1,000,000. Like it never stops. It keeps going down forever if we have all real numbers. And it keeps the other end, it doesn't stop at 5, it keeps on going up to 500, 5,000,000, it never stops. So guys, if you think about the idea of never stopping, like If you keep going down here forever and ever, it's not a number. If you keep going on forever, it's more of an idea. That's what negative infinity means. If you keep going down forever, and if you keep going up forever, that's positive infinity. Do you guys learn that symbol for infinity ever before? It looks like a sideways 8. So in interval notation, remember back on this one how I wrote the lower limit, then the upper limit with a comma between. Well, this time we would say the lower limit would be negative infinity, because there really isn't a limit. It goes down forever and ever. And the upper limit, if it goes up forever and ever, again, there isn't really a limit. It's infinity. And then what kind of brackets do we put? Well, when it's infinity, you actually always use open brackets. That's something you just want to memorize. That's how interval notation works. When it's infinity, you always use the open bracket, okay? So we're going to practice one more. If I wanted to write in interval notation the set of all positive real numbers, think about positive real numbers. It'd be 1, 2, 3, 4, but it could also be like 0.5, 0.7, 3.82. You just can't have negatives if it says all positives. Also, you couldn't have 0 though, because 0 is not a positive number. It's also not a negative number. It's nothing, okay? So if I wanted to draw a picture of all positive real numbers, it would look like this. It would start at 0 and it would go on forever to the right. So how would we write that in interval notation? Well, it starts at 0 and it never stops, because all positive real numbers means it's going to keep going past 5 to 500, 5 million, like it never stops. What kind of brackets do we need? We need an open bracket, because remember I just said 0 doesn't count because it's not a positive number, but you have to start at 0 still. You can't start at 1, because you could have then you're missing all the numbers in between, like 0.5. You're allowed to have 0.5, right? So we have to start at 0, but it's not included though. So we have to have the open bracket. And then remember, I told you with infinity, you always have an open bracket, okay? So again, it's just a different, interval notation is just a different way to write out, instead of writing in words, all real numbers, it's kind of a shorthand way to write it, okay? Now, we're going to be talking today about something called domain, which you learned that in Algebra 1, but it's been a while. You don't really do a lot with that in geometry. So you're going to want to write this definition down in your notes. Domain means all the possible values of x that you can have in a function. And it will change depending on what type of function you are looking at, okay? So if we're looking at the function the square root of x, I want you to think about what numbers you could fill in for x. Can you take the square root of any number in the whole world? Let me ask you this instead. Is there anything that you could not take the square root of? Let's check. That's what last class said too. Let's check it. Let's go to our calculator and try to take the square root of 0 and look what happens. It'll actually just be 0, because 0 times 0 is 0, right? So you can take the square root of 0. What about the square root of 25 we know is 5, right? What if we tried to take the square root of negative 25? You're going to get an error. Do you remember why? Because 5 times 5 is 25, but so is negative 5 times negative 5. There's no whole number times itself, or no integer times itself that would give you negative 25, right? There's an imaginary solution. We learned that back in chapter 1, but there's no real solution, okay? So in other words, I can't take the square root of a negative number. So that means x cannot be a negative number. So if I wanted to say what the domain is, because domain means what x's can you have? We just said we can't have negative numbers. So what you would say is all non-negative numbers would be okay. We have to be careful not to say positive real numbers, because you remember what we talked about on this slide? Positive real numbers doesn't include 0, and 0 is allowed, right? We said we can take the square root of 0. That's okay. So another way to do this, guys, is you could put this in your graphing calculator. Like, let's go to y equals for a second and type in the square root of x. So square root of x. Two different things I want us to look at. Let's go look at the table first. So if you take the square root of 1, you're just going to get 1. The square root of 0, you're just going to get 0. Look what happens when you get to the negatives. See how it says error? Because you can't take the square root of a negative number. Okay? So that means our domain does not include negative numbers. The x's have to be 0 and greater. So another way is to look at the graph. Do you see how on the graph we only have things graphed in quadrant 1? Like, see how the graph just starts here at 0, 0, and it goes to the right? Like, we don't even have any graph over here on the left side, because you can't take the square root of negative numbers. So that's yet another way to know what x values show up on this graph. Not negatives, right? Because there's no graph over there. It starts at 0 and it goes on forever. So it's all non-negative real numbers. How are we going to write that in interval notation? We're going to say that it starts at 0. It does include 0, right? Remember we said the square root of 0 is 0. You can take the square root of 0, and it goes on up forever. So that's how you would write it in interval notation, okay? Let's try another one. What would the domain be? Remember again, domain means what numbers can you plug in for x? That's the definition of domain. So what would the domain of this one be? It's actually easier to ask yourself, I think, is there any number that you could not plug in for x? So in this one, no, because you can square anything, right? I can square a negative number. Negative 7 squared means negative 7 times negative 7. It just is going to make it positive 49. But you can square anything, right? Again, another way to do this that's very helpful is go to y equals and type in your function, 4x squared. And you could either look at the graph or the table. Let's take a look at the table first. We don't have any errors like we did on the last one, right? Like, you're allowed to have -4 as an x value. You can see the output is 64. You're allowed to have 0. You're allowed to have all these positive numbers. Like, look at your graph too. The graph, remember the last one? The graph was like only on the right side of the grid because the x's had to be positive. This time we have x values over on the left and the right, meaning x could be negative or positive. So there's no restrictions this time. So in words, we would say that the domain is all real numbers. Now in Algebra 1, you may have learned this symbol. Do you guys remember learning that symbol for all real numbers? Okay, again, now that you're in Algebra 2, we write it a little fancier with that interval notation that I taught you on the last slide. So if it's all real numbers, remember how we did that one here? This is how you're going to write it because there's no restrictions. You can put anything you want. Like, it goes from negative infinity all the way to positive infinity. There's nothing that you can't plug in here. X can be anything you want on the whole number line, okay? Questions on that so far? We're going to do a couple more domain practice here. So again, domain means what numbers can you plug in for X, but I sometimes think it's easier to ask yourself, is there anything that you cannot plug in for X? So what do you think about this one? Is there anything that you think you would not be able to fill in for X? Any thoughts? I'm going to ask you, what if I fill in 9 for X? Like, what if I put a 9 right here? then I would be doing 9 minus 9, and I would get 0 down here. I want you to go do 5 divided by 0 in your calculator real quick. In case you forgot, you can't divide by 0. It's going to give you an error in your calculator. So whenever you have a function where there's a fraction involved, you have to think to yourself, it would be bad if I had 0 in the denominator. And what would make that happen is if I plug in 9 in place of x, okay? So I cannot have 9 in my domain, in other words. There's not going to be any other restrictions. Like, let's plug it in our calculator. By the way, guys, side note, do you remember f of x is just a fancy way to write y? We learned that back in Algebra 1. So that's why we could change it to y equals if we want and just go plug it in our calculator. When you plug this one in your calculator, be careful. It would be best to do a vertical fraction. If you're going to do it sideways, you're going to need to make sure you put parentheses around your x minus 9, because you have to do that part first technically, right? Like, remember when I filled in 9, I did 9 minus 9, and then we ended up with 5 over 0. So let's look at the table. So far, it looks like everything is okay. Like, we can plug in -4 because we get an output of this. It's an ugly number, but it's an answer, right? The only time you're not going to get an answer, like we said, was at 9. See how it's an error? Every other number after that is fine, okay? Like, literally 9 is the only thing that's not going to be part of our domain, because if you plug in 9, there is no answer. It's not possible because you can't divide by 0. So we could say that the domain is all real numbers except 9, since it can be literally anything on the whole number line except 9. And guys, I'm going to tell you right now, if this were a test or a quiz, I would accept you writing out the answer like that. All real numbers except 9. There is a way that we can write it in interval notation, but I'm going to warn you, it's a little bit hard to understand. I'm still going to teach it to you, because if any of you are thinking about going on to pre-calc next year, you have to know how to do this, okay? But if you don't think you're going to go on to pre-calc, it's probably not as important for you to know how to do this, okay? So again, first thing I want you to know is it's okay to write your answer like this on a test or a quiz. If we were going to write it in interval notation, remember how this means all real numbers on the whole number line. We already learned that. So how are we going to say all real numbers except just that one thing, 9? Well, what you're going to have to do is you're going to have to say it can go from -infinity to 9, but then since 9's not included, we need that open bracket, but it doesn't stop there, right? Like, after 9, it's going to pick back up and go on forever toward infinity, and you have to put this in the middle. It's called a union, okay? Again, I know and recognize, guys, that's a little bit hard to understand. Again, if you're not going to go on to pre-calc next year, you probably don't even have to learn how to write it that way. It's probably fine for you to just write it in words. But I did want to show you one like that, okay? So basically now it's saying it goes from -infinity to infinity, except we don't have 9 in there. That's why we have those open brackets, okay? One more. What if we want to find the domain of 8x to the 1/2? Again, domain means what numbers can we fill in for x? So again, I think it's easier to actually ask yourself, what can you not fill in? Are there any restrictions? Well, let's remember that x to the 1/2 is the same thing as the square root of x, right? So we already talked about the square root of x back here. So it's going to be the same thing. You can't take the square root of a negative number. So it's going to be all non-negative real numbers again, because we can't say positives, right? Because that would exclude 0. But we already said you're allowed to take the square root of 0. It'd just be 0. Okay, so how do we write it in interval notation? Again, it's going to start at 0 because we can't have negatives and go on forever toward infinity. That's how you would write it in interval notation, okay? So now that you have that background information, today we're going to be learning how to do operations with functions. Like I'm going to give you two functions and we might have to add them together or subtract them or multiply or divide. And then we will be talking about the domain of the answer. So I'm going to refer back to this slide periodically. I don't think you really need to write it all down. After class later, if you decide there's parts of it you want to write down, you can go back and copy it from Polaris. So adding and subtracting functions. Remember, guys, that f of x is just a fancy way to write y, but sometimes we use function notation because if there's more than one different function, it's nice to know like f of x means this function and g of x means this function, okay? So if we are asked to do f of x plus g of x, what we're going to do is write down what f of x is, which is 4x to the 1/2, and we're going to write plus, and then we're going to write what g of x is, negative 9x to the 1/2. So we write it out first, and then how do we actually do it? Well, we learned this yesterday. If they're both x to the 1/2, we consider those like terms. So you just look at your coefficients. We have 4 plus negative 9, so that'd be negative 5x to the 1/2. Okay, so then if we want to subtract functions instead, f of x, we're going to write that first. So 4x to the 1/2 minus this time g of x, which is negative 9x to the 1/2. So if it were me, guys, I mean, again, they're like terms, so you can do 4 minus negative 9 if you want, but that would also be the same as just doing 4 plus 9, right? So that one's going to end up being 13x to the 1/2. One thing I want to caution you guys of, be careful the order. Like if it said, see how this one said f of x minus g of x? If it said g of x minus f of x, then we'd have to make sure we write g of x first, right? It matters. We would get a different answer. So be careful on that, okay? Lastly, part C, it wants us to tell what is the domain of f plus g. So what's the domain of this? So how you're going to figure that out, if you go back, I told you I was going to go back to this slide periodically. Look what it says at the bottom. The domain of H, which means like the answer of what we added, is going to be equal to the domain of F and G. So what you're going to have to do is go back to this, and you're going to have to think about what is the domain of this, and what is the domain of this. Well, remember again, guys, how x to the 1/2 is the same as the square root. So this is just like this 4 times the square root of x, negative 9 times the square root of x. We've already talked about the domain of the square root of x. Remember how we said we can't have negative numbers? You can't take the square root of a negative number. So if the domain of this is all non-negative real numbers and the domain of this is all non-negative real numbers, the domain of the answer is also going to be all non-negative real numbers. So again, how do we write that in function notation? Non-negative means it would start at 0 because you can't have negatives. And it goes on forever, though. You can have any positive real number, and you can have 0. You just can't take the square root of negative numbers, okay? So when you're subtracting, it's the same thing. The domain of this answer, you're going to have to think about the domain of f of x, which we said was all non-negative real numbers, the domain of g of x, which we said was all non-negative real numbers. So the domain of the answer is going to be all non-negative real numbers, the same thing. So 0 to infinity. Okay, questions so far at all? Let's try another one where we're adding and subtracting. So it wants us to find f of x plus g of x. So this time f of x is this whole thing. So let's write out 2x to the 1/2 plus 3x to the 1/5, and we're going to add it with g of x, which is this function, 4x to the 1/2 plus or minus, sorry, 7x to the 1/5. So that's how we would write it out. Now you just go and add any that are like each other, right? Like x to the 1/2 and another x to the 1/2. Look at your coefficients. 2 plus 4 more means you're going to have 6 of them now, right? You can't add one x to the 1/2 with x to the 1/5 though. But this, let me use a different color. We could add x to the 1/5 with more x to the 1/5. So it's actually 3 minus 7 we're doing this time. That's going to be negative 4x to the 1/5. So then let's go ahead. Part 3 is going to ask us to do the domain. Let's go ahead and do the domain real quick. Now remember, again, guys, you have to look at the domain of f of x and you have to look at the domain of g of x, because the answer is going to, the domain of the answer is going to depend on the domain of each function by itself. So let's maybe rewrite this. Remember, it's the same as 2x, then the square root of x, right? Remember how x to the 1/2 is the same as the square root of x? This would be the same thing as x, the 5th root of x, remember. So we've already talked about the square root of x multiple times, guys. Remember, you can't take the square root of a negative number. So you could take the 5th root of a negative number. Let's check that real quick. If you take a negative number to the 1/5 power, so let's do like -8. I'm making it up, to the 1/5 power, that's going to be okay. But because you can't take a negative to the 1/2 power, it's going to give you an error, right? Then that means, once again, we're just not going to be able to have negatives at all. So our domain has to be all non-negative real numbers. For f of x, it'd be the same for g of x, because it's to the 1/2 and 1/5 again. Again, to the 1/5, technically you could have any number to the 1/5, but you can't have any number to the 1/2. So that's going to restrict it. The domain is going to be all non-negative real numbers. So again, how you're going to write the domain of this is 0 to infinity, and 0 is included. So we have that closed bracket, okay? Let's do f of x minus g of x. So let's write it out again. F of x, recopy it, 2x to the 1/2 plus 3x to the 1/5 minus g of x, which is this. Guys, I'm going to add parentheses this time. You're going to see why in a minute. G of x has 2 parts to it. You have to make sure you subtract both parts. So what's going to happen, I'm going to just rewrite f of x real quick. It's kind of like distributing a -1. -1 times 4, like you're going to have to subtract 4x to the 1/2. But -1 times -7, it's going to end up being addition. Because if you subtract -7, it's the same thing as adding 7. So just be careful when you're doing subtraction. If your function has more than one piece, you have to make sure the minus applies to all of it. So it becomes minus 4x to the 1/2 and minus -7, which is the same as plus 7. Once you get past that part, now you just add like terms again. 2 of these minus 4 of these would give you -2x to the 1/2. And then let's use a different color. 3 of these plus 7 of these would give you +10x to the 1/5. The domain is going to be the same as when we added the functions, because remember, we already talked about what's the domain of f of x, what's the domain of g of x. The domain of the answer will be the same. So it will just be all non-negative real numbers, which means we have to say it starts at 0 and it goes on forever through infinity. Okay? Questions on that one at all? Okay. What if we have to multiply and divide functions? So let's read what it says. F of x, which is 6x, times this time and then g of x, which is x to the 3/4. So we should write it out first thing. How do we multiply those? You got to use your exponent rules we learned a couple days ago. Guys, you might want to add extra dots in here. This is all multiplication, so it's kind of like doing 6 times 1, and then x to the first times x to the 3/4. Do you remember that you add exponents when you're multiplying? So you have to do 1 plus 3/4. So you can use your calculator if you need to, but 1 is the same as 4/4 plus 3/4. It's going to be 7/4. Okay, let's talk about domain. So again, you have to look at the domain of f of x and the domain of g of x. F of x, the domain could be all real numbers because I can take 6 times anything, can't I? Can I do 6 times a negative number? Yeah, I'll just get a negative number as the answer, but you can do it, right? So for that, the domain's all real numbers, but we got to think about the domain of g of x too. So how about x to the 3/4? Let's think about it real quick. We could either, maybe let's even just plug it in. X to the 3/4. Go look at the table. Negatives aren't going to work because to the 3/4 power, that's like taking the 4th root and raising it to the 3rd. If the root is even, just like the square root, a 4th root or a 6th root or an 8th root, you can't take the square, you can't take the root of a negative. Again, 0 is okay. This root of 0 is of any root would still be 0, okay? But because even though here the domain is all real numbers, because here you can't have negatives, then you're going to have to say that you can't have negatives in your final answer. So it's going to be all non-negative real numbers, which again, we write like this. It starts at 0 and it goes on forever, but you can't have negatives. What if we want to divide f of x by g of x? Let's write it out. F of x is 6x divided by g of x is x to the 3/4. So that's how we write it. How do we do it? Well, again, it's what we learned a couple of days ago. 6 divided by 1 is just 6. And then when you're dividing, do you remember you subtract the exponents? 1 minus 3/4. If you need your calculator for that, great. If not, it's like 4/4 minus 3/4 is going to be 1/4. Now, normally the domain would be like the same thing as we already did on the other one. But with division, there's one extra restriction. This is the only time there's an extra restriction. Remember all the way back on this problem how we said we couldn't plug in 9 here because we would get 0 in the denominator. That's why there's going to be an extra restriction with division, because we can't have, whoops, I forgot my x here. I'm sorry, guys. We can't have this cannot be 0. Like, you know how 0 to the 3/4 is just going to give us 0 is the answer? That's going to be bad because then we would be dividing by 0, and you can't divide by 0. So this time when you do your domain, you're just going to have to, we still can't have any negatives, but we also can't have 0 this time. So you're just going to have to write it like this instead. See the difference? We have an open bracket this time because 0 is not included this time, okay? If you're multiplying, 0 is fine. But if you're dividing, it's no good because you can't have a 0 down here in the denominator, okay? So you have that one extra restriction. We're going to do one more multiplication and division real quick. So let's do f of x, so 3x times g of x, which is x to the 1/5. So remember, guys, when you're multiplying all of this together, you're kind of doing it in parts. Like the 3 times the 1 just gives you 3, but x to the first times x to the 1/5, that's where you're going to add exponents. So you have to do 1 plus 1/5, which is like 5/5 plus 1/5. I can do it mentally. If you don't know how to do it mentally, just do 1 plus 1/5 on your calculator. You would see that it's 6/5. Let's talk about domain real quick. The domain of this is all real numbers. You can put it in your calculator if you want. That's just a line. If we graph 3x, like you have x's on the left of the graph and the right. You can go to the table. There's no restrictions. Like you're going to have an output for everything, right? You can do 3 times any number in the whole world. There's no restrictions. So the domain of this is all real numbers. Guess what? X to the 1/5, if this number is odd, there's no restrictions. When it was 1/2 or 1/4, there were restrictions because you can't take the root of a negative. But again, guys, check it. Let's just plug in x raised to the 1/5. There's no restrictions. Remember when we did x to the 1/2, we had an error for all the negative numbers. You don't have that this time. Like you can plug in any x you want. So once again, the domain is all real numbers. If the domain of f of x is all real numbers and the domain of g of x is all real numbers, the domain of this is going to be all real numbers. Remember how we write that? It goes from negative infinity to infinity. Let's finish with division real quick. 3x divided by x to the 1/5. Let's put our ones in there. 3 divided by 1 is just 3. X to the 1 minus 1/5 is like 5/5 minus 1/5. It's 4/5. Now, again, normally the domain would be all real numbers, but with division, sometimes there's an extra restriction. Do you see how if I plug in 0 here, 0 to any power is 0. So I would get an error because I can't divide by 0. So this is one of those really tricky ones, guys. In words, we could just say all real numbers except 0. In interval notation, you have to say it goes from negative infinity to 0 and it kind of stops for a minute and then it picks back up and goes on, okay? Again, that's really tricky. I would be okay with it on a quiz if you just said all real numbers except 0 for that one, okay?